Hello, hello. All right. So I got the green light from Vitali. So we'll get started after a long hassle. So thanks everyone for joining. Thank you for your patience. Um, I have a talk prepared for you today. So let me share my screen. Let me go ahead. Share screen. If you have any comments, any thoughts, questions, I will still see everything on the channel. So feel free to post something there. I'll address the questions in the end. I know there's sometimes a delay, so we'll see how it goes. So, what I'm going to talk about today is why you don't need Rust, probably, as a Python developer. So, let's get started. So, first things first. Hello, Johannes. Hello, Vitale. Hi, everyone. Thanks for joining. So, for the people that don't know me, my name is Murillo. I am a machine learning engineer at DataRoots. I'm actually from Brazil. Hi, Sophie. I have a background in mechanical engineering, a master's in artificial intelligence, some certifications I got over time. Um, Maybe some fun facts about me. Python is my day to day, let's say. I'm also curious about Rust, so I've been learning Rust for a bit over a year now, a little over a year. I also am a big fan of chickens, so I know that here in Belgium, people actually have chickens in their house, and I think it's a sweet deal. So yeah, I think everyone should have chickens. That's my take on this. I'm also one of the organizers of the Python user group in Belgium. We also, with Bart and some people from DataRoots, we also organize the Data Topics Unplugged podcast. So we try to have some fun and keep things lighthearted. And I'm a tech lead for the AI business unit at DataRoots. That is my day job, let's say. So nice to meet everyone. Um, so my trajectory with Rust, right? Rust, I think, has been very popular throughout throughout the years. I think Python developed actually, like, if I remember correctly, most people that are getting to Rust actually coming from Python, and that's because there's a lot more coming from Rust to Python there as well. Hey Sam. Um, so this is my trajectory, kind of like in November. So that's before I did anything with Rust. I was actually pretty enthusiastic. I was like, yes, let's do this. This is gonna be fun. And then I tried to do the advent of code. So last year I just said like, okay, let's do it in Rust, and my motivation dropped substantially very quickly. Right. I think in the beginning I was still excited. Like day one didn't work. Okay, day two, okay. Then after day 4 or 5, I was like, I'm struggling too much. I think I should stop and learn. Then I did the Rustlings, which is, if you don't know, it's kind of like an exercise based way of learning, which I thought was pretty cool. Um, and then this kind of went on and off, right? Like I said, as I said, my day job is a tech lead for AI, right? So machine learning engineer. So as you can imagine, I'm doing more Python more often than not. So on and off, I started working on a research project called Fire to Sort that we were diving into Rust a bit more. I also did some other things. Yeah, well, I I manufactured this Vitalis. So yes, only one sad face, but there was a lot of crying in that period. It was very dark times. And then after that, I actually did some things. I was basically looking for excuses to use Rust to learn a bit more. So there was like a tennis booking thing that I was trying to book every week, and I actually was able to do it. This was successful, but it took way longer. And maybe a fun sad side story is that I was able to do this. I was able to book one week. I was able to book the court automatically, and then the next week the whole website layout changed, so everything was outdated. And ever since, I never used it. So it probably took me a couple of months to get this working. I was able to benefit from it once and then never again. So okay. Then I actually went to some PyCons to do a project, like to present a little use case, a little showcase about how to make Python faster. So I actually compare different ways to make a Python program run faster. And one of these ways was actually using Rust. So you're creating Rust and you bind it into Python. I also did a workshop, Introduction to PyO3, which is the library framework that you use to bind Rust applications to Python. And I also did some very small live demos, like live coding sessions. So this is kind of what I've done in this period of 1 year. So I like Rust. I think it's fun. Some people would call me a fanboy, but I decided to take a 360 turn, or actually not 360, 180 turn to say why I don't. After all these experiences, what's my take when I think it should be used, when I don't think it should be used, etc., etc. And talking about 360, let's do a 360 on Rust very quickly, right? So maybe first thing is that this is the mascot, Fairies the crab. So Rust people are known as Rustaceans, right? So it's like crustacean kind of thing. So fun, fun, fun. So first thing is that you probably heard about Rust, and Rust is super popular. Actually, it's been voted for 8 years in a row as the most loved programming language. It's also compiled. It has strong types, right? So it is strongly typed and whatnot, and statically typed. So we're gonna dive it a bit deeper into it in a bit later. It is memory safe, so that's one thing that people boost quite a lot about. But there's no garbage collector, so another thing that you details in details. And they actually use this ownership and borrowing, which we'll touch a bit very high level later as well. The arch nemesis of Rust is actually C++, I would say, right? So they both sit in that systems engineering and very fast programming languages space. Um, One thing that you're gonna feel if you're actually programming Rust is that there are no exceptions, but there are results. So basically, the way you handle errors is different in Rust. It has, I called it a true optional type, because in Python we also have optional, but it's really just a synthetic sugar for having int or none, right? So that's the same thing in Python, or actually using the pipe operator, right? Um, if you know, if you ever heard of any library that uses Rust in the back, they usually say it's light and fast, right? So that's what you see again and again. Um, Rust plays nice with C, and that's actually how it actually interacts with Python. Python, the most popular Python interpreter, is actually C Python. So that's actually how it plays nice with it, and because of that, you can actually interact with other languages, including C++, right? And if you're coming from Python like I did, and you go into Rust, the first thing you're going to feel is that it kind of feels like a Python, but it is compiled. And also there is like a strict MyPy. So because the types need to be enforced, right? So that's kind of high level. If you want to kind of imagine what it feels like, it's kind of like that. A lot of kind of put a lot of salt in that statement, but that's kind of it. And I see a question for Vitalis. Supported paradigms, object-oriented programming, functional, something else. It's not actually, well, structs, right? They actually don't have inheritance, so it's like composition. It has like the functional stuff as well. You can actually do as well in Rust. They kind of force you more towards like this chaining operations kind of thing. Like yes, I see the the crab there. Yeah, it's a bit different. I'm not gonna go too much into detail of what Rust ins and outs, right? But there's quite a lot there. But this is just the first look, let's say. So why Rust, right? Like, why would anyone opt to do stuff in Rust? I think first answer is pretty obvious. It is fast. Um, Second, it's kind of obvious, but only if you kind of follow the hype train, let's say, is that it's safe, right? And we'll see what it mean by safe here. Um, Ideally, what I hear as well, like from podcasts, I don't have that much experience, but people say that you pay the cost of developing in Rust once, but then it has way less bugs. So you build it once and it kind of always runs. You don't have to worry about this, but I haven't experienced that firsthand yet. Um, so in a way, you kind of pay the cost up front. So the compiler is very picky. It doesn't let you do a lot of the things that you would like to do. But once it compiles and it runs, you can be more rest assured that things are going to run well. And the last and maybe the stronger reason to become a Rustacean is to join the hype. um, so make friends, you can flex, you can drink from the Kool-Aid as well, right? So I think there's a lot of Rust hype these days, which is definitely true. And I think that there are people that are going for Rust. It's a bit hyped, right? So let's not forget that. That's the latest and greatest, let's say. So if you want to join the Kool-Aid, drink the Kool-Aid, right? Oh yeah. So it's part of it. So, okay, but do we need Rust, right? Do we need this? So let's look at a couple of statements we have there. First is Rust is fast. Um, do we need this speed, right? So when I first started working with Python, or actually in general, right? Like if you open your ears out to what people say, Python is deemed as a slow language, right? Um, so you hear this everywhere, like Python is slow, Python is slow, Python is slow, right? Which actually confused me a bit when I first started working, because on one hand you hear Python is slow, but on the other hand you hear the machine learning requires a lot of computational power and all these things, right? But this is a big statement here. But to be clear, that slow and fast is like what people feel, but it's not they're different types of speeds, let's say. So for example, well, maybe you're talking a bit more about CPU versus IO bound. And if you're not familiar, I prepared a little analogy here. Hopefully it resonates a bit. But the idea here is, well, high level is you have computational speed and you have IO speed, right? Um, let's imagine you're like a baker kind of person. And 1 second. And you need to make bread, right? So how early your customers can actually get that bread depends on how fast you can make bread, but also depends on the delivery, right? In CPU bound stuff, basically is like the speed that it takes or how long it takes to make bread. And IO bound stuff is how long it takes to deliver, right? Which maybe it's obvious, but for example, if you're the fastest bread maker, but you have only one bicycle that needs to deliver bread to your customers and back, maybe making bread even faster is not going to help you with the clients, because most of the time is spent actually delivering the bread, right? So in those cases, you can actually maybe have more bicycles, or you can maybe get a motorcycle, right? Which in more realistic, let's imagine you have a machine learning model with a REST API, right? If you can make predictions very quick, but then you have 1 trillion requests, there's only so much this guy can do, even though it's fast, right? So you can probably scale horizontally or you can scale vertically, right? Which in this case, in this analogy, would be like getting more bicycles or getting a motorcycle. So you can deliver things faster. And I'm saying this too because most of the, well, if you look at what a Python applications are built today, there's a lot of web stuff, right? So like fast API and whatnot. And a lot of the times, actually, the thing that takes the longest is the network latency, right? The IO stuff. So having Rust will help, yes, but it won't solve all your problems. And if you're just waiting for the network to give a response, then you're still gonna wait, right? So be a bit critical about that. And the last thing as well that I'll say before moving on is that what is actually fast for you, right? Sometimes in real time, real time use cases, right? People say it's real time, but is real time for you a few seconds? Is real time for you half a second, 1/3 of a second? Is it maybe actually 10 seconds? Like, what is the actual use case? What are you willing to tolerate, right? Because this also plays a role. Rust, it is faster, right? So I think this is pretty obvious. But there are also ways to make Python faster, right? Like Python being fast or slow is not a new thing. So actually, Python 3.11, there was the faster C Python, and on Python 13, they're going to try the no-GIL thing. So they're aside from that. So this is just recent developments, but there are actually way more alternatives out there, right? So for example, PyPI is a just-in-time compiler for Python, which makes things much faster. There's also Cython, Codon, which is kind of like a Python compiler kind of thing, which make your code much faster. Numba, which is another just-in-time compiler. Mojo, which is like a Python superset. Actually, it aims to be that. It's not quite there yet. And MyPy. So MyPy is usually known for the static type checking, but there's also MyPy, which actually creates C extensions from your Python code and installs it back in your environment, right? So all these things are uh, are possible. So just to kind of give you an idea, here is a small comparison by running Fibonacci number from 40th Fibonacci number, first using MyPy and MyPyC with the C extensions, right, to see how long it takes. Originally, this actually took, I want to say, like 40 seconds or 30 seconds, but then actually you can compile this with MyPyC, and then again, it takes 1.622 seconds. So actually pretty fast. In Rust, so this is something that I did before. I'm kind of reusing these demos. For Rust, we actually compared this still binding into Python, right? So actually, if you just did it in Rust by itself, it would actually be way, way faster, right? But let's have a look how this goes. So first you have to write the code in Rust, of course. And then here I'm using Maturing, which is a CLI tool to actually compile the project and install it in the active Python environment. And then I can actually time it. So I do it once. So just actually compiling and trying it on. It takes 2 seconds, so more than MyPyC. But actually, you can actually go even faster. You can actually pass the release flag, which actually will optimize a lot of stuff for you. And then when you run it again, you see that it goes to 0.7 seconds. So it is much faster. But, well, so I guess it's like points Rust, right? So I guess maybe that's your takeaway. But Rust is faster. And I think that's kind of expected, kind of obvious, right? And I guess some people could make the argument that if it runs faster, you pay for less the computational time, so it is cheaper as well. But Rust also takes much longer to develop, and that's because it's compiled. You have to manage memory. There's a lot of other stuff you need to worry about, which increases the complexity, which actually slows you down quite a bit. And if you think that you're paying developers to build these things, then I guess it is more expensive, right? So I guess the real takeaway here is that it depends, right? It's not necessarily point to Rust. I think it depends on what is fast for you. Are you CPU bound? Because again, if you're waiting for the network, doesn't matter, right? Like Rust can be as fast as possible, but the network's still there. You still need to scale horizontally, vertically, whatever. And the other thing that Python is very popular because there are already a lot of C++ bindings, right? So PyTorch, TensorFlow, all these things, OpenCV, they all actually work by being written in C++ and having a small Python layer on top of it. So the question that I have looking at all of this is it worth it, right? Is it still worth it, I guess, right? I guess each person needs to answer for themselves. Second big statement from Rust, and I see there's a Dataroots actually put a bit Rust be king of the programming C, safe. Actually, I can do this. Let me try. Rust be king of the programming C's, safe clamshell with speed like a shellfish. Nice. So this is the Captain Clock clicker. I have a feeling it's a bit LLM-y or GenAI-y related, but yeah, thanks for the addition there. All right, so second statement, Rust is safe, right? So that's what people say a lot of the times, but let's a bit qualify that statement. In the end, what we want is less bugs, I guess. But when people say that Rust is safe, what they're really talking about is memory safety, right? So how do they do that? Is like through this ownership and borrowing, right? So there's actually no garbage collecting, and you can actually have unsafe code, right? You can break these rules. We're just using this unsafe keyword here, right? So maybe just to give a better feel for what I mean by this, let's take a very simple example, right? Everything is an entry point is the main function in Rust, right? And if you go through this small block, right, you're creating a scope. So in the beginning, there's no S variable because it's not declared. Here it's declared and you can actually do stuff with it. But as soon as you get out of this scope, S becomes not valid again, right? So basically Rust will remove it from memory saying like it's not there. And because you have these strict rules, it's very easy for the compiler to say, hey, you're trying to access a variable that doesn't exist anymore, right? That's how Rust maintains its safety. So and how what's the borrowing kind of thing or transferring ownership, right? So you can create again a variable here. Whenever you equate these things without cloning, right? I'm actually saying now that this S2 will own S1. And then if I try to actually print S1 again here, because I transfer the ownership, this would actually give me an error, right? So again, these are all things that Rust will do to try to ensure safety, right? And these are just some examples that I took from the docs. So is Python safe, right? I think Rust is praised as a safe language, but I personally never had to worry about Python being safe. So is Python safe? So the short answer is not really, but you don't have to worry about it. So when is Python not safe, right? So let's have a look. This is just a artifact manufactured example. So I'm using Python 3.12. So actually you can import C types, which is actually built in. You can create a variable, and from the C types API, you can actually free the object in memory, right? And then whenever you try to call that object again, you see that you have this segmentation fault, right? So this is more to say like, yeah, okay, you can say Python is not safe, but really like if you're staying away from the C types thing, you really don't have to worry about it, right? And I never had to really go into this. I mean, I've seen people use C types when they are binding Rust natively, right, without using Maturity or another CLI tool. But the reality is that you really don't have to worry about. It's pretty much battle tested, and I find it very unlikely that you have memory issues with it. So, but you can also say another thing that people, this is not as obvious, but some things that people boost about Rust is that it's the type system, right? So Rust has a very expressive type system, and you can catch a lot of bugs with this. So Python is not, doesn't have this robust type system, right? Like Python is dynamically typed, but we can also run static type checking with MyPy. So the same tool that we can actually compile to make fast extensions, we can actually use to run static type checks. We can also check them at runtime, and it actually relieves a lot of burden from tests, right? So let me try this as well. So if we look here, let's see if this works. Let's imagine this is the input space. Let's imagine that we write a test here, right? We can cover, make sure that this is not there. We can actually write tests, another test here to make sure that we catch this use case. Another thing you could also do is to run a parameterized test, right? Which actually covers a whole bunch of these cases here. Maybe you're super smart and you actually do some property-based testing here, so you actually cover a big area. But by using types, there's actually a whole bunch class of things that you don't have to worry about. Right? Let's imagine that these are all strings and you don't have to cover all these tests here. Let's imagine that now these are all sequences, right? So all lists, and you don't have to worry about these things here. And then you can actually focus on writing tests for the things that are not covered by the types, right? So in a nutshell, actually writing these, making sure that you have static type checks would actually relieve the burden from writing tests for everything, right? And in the end, it will make your program safer because there will be less whoopsies because turns out that the type of the input is different than what you expected, right? Static typing will slow you down, right? So anyone that uses MyPy on strict mode probably have experienced this, but probably not as much as rewriting Rust because again, the type stuff is just part of it, right? It's not. Rust also has the memory management, let's say. So if safety is what you're looking for, there may be other ways to do it in Python already, right? And we're almost there. Hopefully people are still with me. So yeah, you can say I get it, but there is a place for Rust still. And yes, that's true. There are arguments for using Rust. So for example, Rust actually, because of its popularity, has a very nice ecosystem, even for things like web APIs. So if you want to use it there, I think it is something that you see popping up. There's also CLI tools, right? So I think compared to Python, there's the benefit that it's compiled. So the dependencies and all these things for CLI tooling, I think it's a bit ahead, to be honest. And there is also a nice ecosystem for this. SDK cores, right? So this is something that I've seen. I thought it made sense that I think Temporal, they have the core SDK written in Rust. And that's because Rust can be binded into Python, but also Node or other languages because of the C interoperability, right? So you have the core thing in Rust, and then you have layers on different languages. So you build it once, and then you can actually bind it to different languages. Rust also has the WebAssembly story compared to Python. Python also has WebAssembly now, the WASM, right? But it didn't have before. So even maybe another fun fact, Rust had so Python's main interpreter is written in C. Someone thought that would be fun to write a Python interpreter written in Rust. And the main use case that they had originally was actually that you could run this on the browser because Rust can compile to WebAssembly, right? But today it's a bit less relevant. So aside from the ecosystem, there are some also classic use cases, right? So for example, systems engineering, right? So if you need to write an operation system or something that needs to be fast, something that is running all the time, edge devices as well, where memory is constrained. Game development, so things that there's a lot of graphics, a lot of images, right? Stuff that needs to be very dynamic. It's something that I see popping up from, I don't know, reading blogs, podcasts, et cetera, et cetera. Data and machine learning libraries, namely, I think Polars is one of them. Actually, Hugging Face has some stuff like the tokenizers. They're using Rust now. There's actually like this what's it's BERT, BERT. There is a library for running Hugging Face models as well. So there's some stuff popping up for machine learning. There is also a lot of stuff that is Rust binding for the C++ because again, Rust plays nicely with the C stuff. Computer vision, I think it's something that makes sense, even though I don't see as much as well. So, bottom line is yes, there are use cases for this, but probably not for you if you're a Python developer, right? There are all these things, but if you're a Python developer, either you're using another underlying C++ library that kind of does the heavy lifting for you, or you're not doing these things, probably. And if you have any more, like any curiosity, right, you can go to Mozilla's wiki and you can see the are we yet, right? Like the are we learning yet? Are we web yet? So you can see the state of Rust for all these different domains. So to wrap things up, right? Rust, yes, it is much faster, but you kind of pay for that speed during development, right? So it does slow you down. And I'll address your comment in a bit, Nick. Rust is safer, I guess. Usually, when people talk about safer, it's like memory safety, but also there's the safety that brings from types, right? And Rust has a big community. It is very popular, and it has a rich ecosystem as well. Python, on the other hand, it is slower, but there are a lot of libraries and tooling that makes things faster, like PyPI. Python is much faster to prototype and develop, right? Most of the times, this is my personal experience at least, it is fast enough, right? For the use cases that you see Python, most of the time it is fast enough, right? Like we don't need something that is much faster. A lot of the times the bottlenecks are in other places. You can increase the reliability via typing as well. And Python also has a community. It also very popular and it has also a very rich ecosystem here. So I think again, in the end of the day, is having the right tool for the job. If you have a hammer, maybe everything looks like a nail, maybe not. But I guess my takeaway from this is that if you're a Python developer, my guess is that learning Rust is more of a conscious decision than something that you had to do it because that was the only solution for it. And that's kind of it. So thanks everyone for listening. I saw some comments which I also appreciate a lot. I have one particular comment from Nick. So Rust is greater than JavaScript is greater than Rust, right? Um, won't comment on that, but there is some things that are, for example, built in Rust that can be binding to the node, right? So it can be run on the browser and all these things. So I'm not no comment, Nick. If anyone has any questions, I think I looked at everything that was on the chat. If anyone has any questions, let me know. But otherwise, thank you a lot for being here with me, and I'll see you next time.